Hi, I am Syed on Maths Online. Today we are going to discuss about properties of Laplace transform. In the previous few videos we have discussed about two different properties. Today we are going to discuss about the third property of Laplace transform. If L of f of t is equals to f bar of s, then we have Laplace transform of f of t by t will be equals to integral s to infinity f bar of s into ds. So let us take few examples based on the Laplace transform. Let us start with the first example. Take the first question. Find the Laplace transform of 1 minus e power of minus of at divided by t. So if you try to observe over here in the numerator, you can see you are having f of t. So here in the numerator 1 minus e power of minus at will be acting as your f of t. So this t in the denominator, you have t in the denominator, which means that if you try to observe over here, when you try to find out the Laplace transform of this f of t, you will be getting f bar of s. So the only thing that you have to do is just find out the Laplace transform of the numerator value. You will get this f bar of s. So let us try to find out the Laplace transform of the numerator. So I will be taking the value of the numerator to be f of t. F of t will be 1 minus e power of minus of at. So if you take the Laplace transform of f of t, which is nothing but Laplace transform of 1 minus e power of minus of at. So apply the Laplace transform individually for each of the terms. So you will be getting Laplace transform of 1. We know that Laplace transform of a will be equals to a by s. So a value over here is 1, so it is 1 by s. And we have Laplace transform of e power of at. E power of at is 1 by s minus of a. Or if you have Laplace transform of minus at, in that case we will be having 1 by s plus a. So if you try to write down the Laplace transform over here I will be getting 1 by s plus a. So this will be acting as your f bar of s value. So I have got this f bar of s. So now if I try to divide over here Laplace transform of f of t by t, so I will be getting the expression to be equals to integral of s to infinity f bar of s into ds. So now just plug in the value of f bar of s that we have got, so which will be equals to integral s to infinity, your value of f bar of s is 1 by s minus of 1 by s plus a times of you have ds. Apply the integral separately for each of the terms. First term integral s to infinity 1 by s into ds minus integral of s to infinity. The second term is 1 by s plus a into ds. So we know this basic formula, integral of dx by x. Its formula is nothing but log of x. So using that formula over here, you will be getting the value to be equals to log of s minus, here also you will be getting log of s plus a. But both the integral are having the same limit values. So you can write down the limits to be s to infinity. But we know the properties of logarithm. It is in the form of log m minus log n, which can be written in the form of log of m by n. So it can be written in the form of log s by s plus a. Limit values will be the same, s to infinity. So if you apply the upper limit value is infinity, limit as s tends to infinity, you have the value to be equals to log of s by s plus a. This is the upper limit value. Minus of the lower limit value over here is s itself. For s you have to replace s only, so you will be getting the same expression, log of s by s plus a. So I have written the upper limit value minus the lower limit value. So the first term s is tending to infinity, so you have to simplify this expression in such a way that you avoid that infinity value. So for that I'll try to simplify. It is log of. So I'll take s common outside and rewrite this term to be s common here. You will be left out with 1 plus. It is a by s. So what happens? This s over here and s over here will cancel out. And this term log of s by s plus a will be the same. So if I apply the limit in this case, I'll be getting log of, it is 1 by 1 plus a by infinity. Anything by infinity will be what? Anything by infinity will be 0. So it is minus of log s by s plus a. So you'll be getting log 1 value. Log 1 minus of log of s by s plus a. So log 1 value is how much? Log 1 will be 0. So therefore I will be writing this value to be 0 minus, you have log of s by s plus a. Now because negative sign is there, if I take negative sign inside, I will be getting log of s plus a by s. So it becomes reciprocal. That is the required solution we have. But if you want to do this problem directly, as we know that this particular simplification that we have done over here, starting from this step onwards, right, we have seen that s is tending to infinity. You have taken s common outside and this log of s by s plus a has remained. So starting from this step, right, starting from this step till here, if you try to observe this expression, ultimately I have made this first term to be 0. You will be left out only with this particular term, negative of. Can you see over here that negative of log s by s plus a is repeated over here, which means this entire expression that I have done, I have made this as 0, which means for every problem, whenever s is tending to infinity, whenever you have in the numerator s and in the denominator s, ultimately the value will reduce to 0. So if you want to do it directly over here, you can directly write this expression to be equals to 0 minus, what do you get? Log of s by s plus a. This is how you can do it directly. You can do this. So we have got the final solution to be equals to, there is log of s plus a by s. Let us move on to the next question. Find Laplace transform of cos of 2t minus cos of 3t divided by t. So whenever I have this expression in the form of f of t by t, first you need to find out f of t value. So find out f of t. So f of t is a numerator value. It is cos of 2t minus of cos of 3t. So find out its Laplace transform. So if you apply the Laplace transform on both the sides, so you have Laplace transform of cos 2t minus of Laplace transform of cos 3t. So which will be equals to, will be s by s square 2 square minus of, it is s by over here s square plus 3 square. If you try to simplify, you will be getting this value to be equals to s by s square plus 2 square will be 4 minus, it is s by s square plus 3 square will be 9. So this will be acting as your f bar of s value. Now if I divide f of t by t, you will be getting the formula to be equals to Laplace transform of f of t by t. You will be getting the formula to be integral s to infinity f bar of s into ds. So now if I write down Laplace transform of f of t value, we know it is cos of 2t minus of cos of 3t whole divided by t. This will be equals to, it is integral s to infinity f bar of s. F bar of s is over here, it is s by s square plus 4 minus of, it is s by s square plus 9 times of it is ds. Now we'll try to find out its integral value. So try to apply separately integral s to infinity. It is s by s square plus 4 into ds minus of again integral of s to infinity. It is s by s square plus 9 into ds. So this integral looks similar to this formula dx by x form, which is nothing but log of x, which means that you are having an expression in the denominator, its derivative is in the numerator, right? X differentiation is dx. In the same way, s square plus 4 is there in the denominator, its derivative s square differentiation should be 2s over here. So 2 is missing. If you want to write 2 over here, which means I am multiplying by 2, therefore I have to divide by 2. So just multiply by 2 and divide by 2, so that s square differentiation will become 2s plus 4 differentiation will be 0. So we will be getting 2s by s square plus 4. In the same way, in this case also s square plus 9 is there. S square plus 9 differentiation will be 2s, because you are multiplying by 2. To compensate for that, I have to divide that by 2. So now both these integrals are in this form dx by x. Its solution will be log of x form. So therefore I can write that value to be equals to 1 by 2. You will be getting log of x, that means the denominator value s square plus 4 minus half times of, here also it is log of the denominator value s square plus 9, and both the integrals are having the same limit values. So therefore I can write down the limits to be equals to s to infinity. I can take half common outside. So if you take half common, I will be getting the value to be equals to half times of, you have log of s square plus 4 minus log of s square plus 9. Limit values will be s to infinity. Or further, if I try to rewrite it, it is 1 by 2 times of log m minus log n can be written as log of m by n form. So s square plus 4 divided by s square plus 9, and the limit values are from s to infinity. So once again, let us apply the upper limit value as well as the lower limit value. So we get the expression to be equals to, it is 1 by 2 times of, so upper limit value is limit as s tends to infinity. So we will be getting the value as s square plus 4 divided by s square plus 9, the upper limit value, minus the lower limit value for s will be s itself. We will be getting the same expression log of s square plus 4 divided by s square plus 9. As I told you in the previous problem that limit as s tends to infinity, when you have the same powers of s both in the numerator as well as in the denominator, it will tend to 0. So the entire limit value will become 0. So you can just write it as 0 minus, you have log of s square plus 4 divided by s square plus 9. Because you are having negative sign, if you want to eliminate the negative sign, if you take negative sign inside, it becomes reciprocal, that is s square plus 9 divided by s square plus 4. Or I can rewrite this to be equals to log of s square plus 9 divided by s square plus 4. S square plus 4. So what will happen to this half will come to the power, just using the properties of logarithm. Power half represents square root. So therefore I can write this expression to be equals to log of, it is square root of s square plus 9 divided by s square plus 4. So that's the required solution. Let us move on to the next question. Find Laplace transform of 2 sine of t into sine of phi t divided by t. So we have to take the numerator value to be equals to f of t and find out its Laplace transform. So it is 2 sine of t into sine of phi t. Because it is in the form of the product, you have to convert the product in the form of sum and then try to find out its solution. So the basic formula that you have for this expression is, we know this formula, 2 sine A into sine of B. So the general formula that you have is cos of A minus of B minus of cos of A plus B. This is the formula you have. 2 sine A sine B will be nothing but cos of A minus of B minus cos of A plus B. So if you use this particular formula over here, you will be getting the value to be equals to, it is cos of A minus of B. So in this case, your A value is t, B value is phi t. So A value is t minus B value is phi t minus cos of A plus B, that is t plus phi t. So this will be nothing but cos of t minus phi t will be minus 4t. It is minus of cos of t plus phi t will be 60. But we know the value of cos of minus theta. Cos of minus theta will be nothing but cos theta itself. So using that result, I can write this cos of minus 4t to be equals to cos of 4t minus cos of 60. So we have expressed the product in the form of sum or difference. So here it is in the form of a difference. So I can apply the Laplace transform on both sides. So Laplace transform of f of t. So if you apply the Laplace transform individually for each of the terms, minus Laplace transform of cos of 60. So which will be nothing but Laplace transform of cos 4t will be s by s square plus a square. A value is 4, so 4 square, minus it is s by s square plus a value in this case is 6, so 6 square will be getting. Or further, if you try to simplify this expression, you will be getting the value to be equals to s by s square plus 16 minus of s by s square plus 6 square will be 36. So this will be acting as your f bar of s value. Now if you try to divide this f of t value by t, then you have the formula to be equals to integral of s to infinity f bar of s into ds. So now plug in the value of f of t as well as f bar of s. So you have Laplace transform of your f of t value is nothing but 2 sine of t into sine of phi t whole divided by it is t. That is nothing but integral s to infinity. F bar of s value is known over here. It is s by s square plus 16 minus s by s square plus 36 times of ds. F bar of s into ds. You apply the integral separately for each of the terms. It is integral s to infinity. It is s by s square plus 16 times of ds minus integral of s to infinity. It is s by s square plus 36 times of ds. So once again, as we have done in the previous example, the derivative of s square plus 16 will be 2s. So multiply by 2 divided by 2. Here also the same thing, multiply by 2 and divide by 2. So in that case, you will be getting the integral to be equals to half times of, you get log of s square plus 16 minus half times of log of s square plus 36. Just using the basic formula of integral of dx by x to be log of x, and both are having the same limit values, so you can write down the limits to be equals to s to infinity. You can take half common outside and rewrite the expression to be equals to log of s square plus 16 minus it is log of s square plus 36. Or further I can rewrite this to be equals to half times of log of. So it is log m minus log n will be log m by n form. So s square plus 16 divided by s square plus 36. Limit values is s to infinity over here. So half I'll take common outside. The first term is limit as s tends to infinity, upper limit value. So you have got log of s square plus 16 divided by s square plus 36 minus the lower limit value for s will be s itself. So that term will remain as it is, s square plus 16 divided by s square plus 36. As I told you earlier that whenever the powers of s both in the denominator as well as numerator are the same with log, then the value will reduce to 0. So the first term will become 0 minus you have log of s square plus 16 divided by s square plus 36. Or you can rewrite this as half times, because the negative sign is there. If I eliminate the negative sign inside log, it becomes reciprocal. It becomes s square plus 36 divided by s square plus 16. Or this can be written as log of s square plus 36 divided by s square plus 16. The power will come on the top, just using that log m power of n to be n log of m formula. Or power half represents square root, so log of square root of s square plus 36 divided by s square plus 16. That is the required solution we have. So that's all I have for today. Thank you.